Hello, welcome to the lecture series on vehicle dynamics. This will be the last topic. So here I just would like to demonstrate how various calculations can be done while designing the suspension linkages. So suspension design process involves selecting appropriate vehicle level targets. Selecting appropriate vehicle level targets. Which are all those vehicle level targets? Maximum steady state lateral acceleration, that is v squared by gr. What should be the maximum value? Roll stiffness, which we talk about, k5, which is nothing but ks by 2 s square. Suspension linear stiffness, distance between springs. Ride frequencies, fr, it is 1 by 2 pi root of k roll rate. Okay, k roll rate front divided by front this thing. Okay, a roll rate, rr for the front. Hey, this is rear. Let me write this as ff. Okay, then fr, that is 1 by 2 pi root of k roll rate rear divided by w by g by g. Okay, all right. So we will take rate frequencies. Lateral load percentage distribution front to rear. Okay, that is one other important thing. So taking turn, lateral load distribution, how much here, how much here. Roll moment distribution front to rear. I think I have done M5 front. This is M5 rear. This should be greater than this, I said, for under staircase. Ride heights at various states of load. Okay. Under stair gradient K. Turning radius R. Ackerman, that's fine. Jones travel, how many millimeter or centimeter? Rebound travel. This is what appropriate vehicle level targets. Selecting system architecture. System architecture, one thing that is also very important, whether it is front engine, front wheel drive, front engine, rear wheel drive, like that. For the front suspension, the following need to be considered. Type of suspension. Okay, after that, type of suspension. MacPherson strut or double wishbone for the front. Type of steering actuator, whether rack and pinion or Whitman arm, recirculating ball type. Location of the steering actuator in front of or behind the wheel set. Rear suspension, there are many more possible suspension types in practice. You have to choose that. Okay, Right, selecting system. Choosing the location of the hard points or theoretical center of each ball joint or bushing. How much toe you should have. Camber positive or negative. If so, how much? Caster value. Roll center height or design load. Mechanical caster trail. Okay. Steering returnability, that is very required. Anti-dive, anti-squat, how much percentage we should have, so that this will give you a location of the linkage. Kingpin inclination, scrub radius positive or negative. Okay, spring and shock absorber motion, that is wheel ratios. Bump steer allowed. Roll steer, tractive force steer, brake force steer, camber gain in roll, caster gain in roll. Okay, roll center heights gain, Ackermann change with steering angle, track gain in roll. And track gain in roll. These are some of the hard points, right? This we have to set the values. Next is selecting rates of the bushings for compliance. That's one part. Then analyzing the loads in the suspension. So analyzing the loads in the suspension, see here, basically what we would like to say is, so if you look at the wheel from here, you have the vertical load, maximum lateral load, maximum traction load. This is traction load. Okay, that is one part. Vertical load maximum. Similarly, what is the maximum lateral load? Once we know all these loads, then we can go back to our, system like this. So here you can see we should be able to calculate, this knuckle joint, stub axle, then load up. This is the upper control arm of the suspension, lower control arm of the suspension, roll center height. This is roll center. Then we can do the mechanical load calculation for this linkage, tie rod, from tie rod to then rack and pinion and control arm, all these kind of thing. Okay, this you can say upper ball joint, outer end of the tie rod, inner end of the tie rod, lower ball joint of the control arm. Okay, right. So these are all the calculations we can carry out. To calculation this carry out, once we have the load from here, then we can start projecting that load. Look here, and making force balance and moment balance, it is possible to calculate the loads and the various distances. So this is simple mechanics calculation. So this is how we can decide. First, it is necessary to decide the complete, structure of the vehicle. After that, it is possible to do only simple mechanical calculations, and from whatever vehicle dynamics knowledge we have gained, from that it is possible to do all those calculations and complete the suspension design. Then once suspension design is done, then we can create a geometric model of the vehicle. And this geometric model of the vehicle, then what we can do is we can simulate. Okay, this we can do it in first Adams, and we can simulate considering various road models, and we can tune the parameter. Okay, and we can perfect our vehicle dynamics design. Vehicle dynamic design. Once vehicle dynamic design is there, then we can perform the mechanical design. Okay, so I think whatever you have learned, this will help you to perform simulation on Adams, as well as if you want to model some of these things on MATLAB, and you can and perform simulations and uh, probably designing car, right? You can start working with some experienced people with this knowledge. So thank you very much